Question number 4. A teacher coaches their school table tennis. Adjustable table machine helps practice. The speed is normally distributed with a mean of 10 and a standard deviation of 0.8. Probability bigger than or equal to 11. We're looking for the normal, CDF, from 11 to infinity, 0.8 and 10, and that gives me 0.105649, 3 decimal places, 0.106. Find the value of K, which 80% of the ball speeds are below. Your answers, okay, so K must be over here somewhere, so that area there is 0.8. I'm going to do an inverse normal. I want the left to be 0.8. That's 0.8 for the standard deviation, and that's 10. On my calculator, left 0.8. Standard deviation is also 0.8. And my mean is 10. And that gives me 10.6732. 1 decimal place, 10.7 is what I'm after. Okay, part C. Teacher adjusts the height settings of the ball machine. Now shoots above. Unfortunately, you see 8% do not land on the table. Let P hat be the random variable to represent the several proportion balls that do not land. That's do not land. So P is 0.08. So the mean of P hat will equal P, which will be 0.08. And the standard deviation of P hat will be the square root of P 1 minus P on N, which is 25, which will be no decimal places, so I need to do it exact. 0.08 times 0.92 divided by 25 equals the square root of 46 on 125. Use the binomial distribution to find P hat correct to 3 decimal places. I always turn this into X, where X is P hat divided by, the P hat is X divided by N, therefore X is P hat times N. So the probability of X being bigger than 25 2.5, which equals the probability that X is bigger than or equal to 3, where X is binomial 25 and 0.08. Interactive distribution, discrete binomial CDF, we're going from 3 to 25, where N is 25, probability of success is 0.08. And that gives me 0.323166, 3 decimal places, 0.323. Let the teacher adjust the spinning settings of the ball machine. The spin, measured in revolutions per second, is a continuous random variable X. So this is my X. This is the revolutions per second, and this is the probability density. Find the maximum possible spin. 50. Because we've got some rule to there and some rule to there. 50 is the maximum possible spin. Find the median spin. So we're looking for a half. Okay. So I reckon the median is going to be in there somewhere. Just double check that. So if I go the integral from 0 to 20 of x divided by 500 dx, and that gives me an answer of 2/5. So that's 2/5, that's 0.4, so it is going to be over here somewhere. So if I go from 20, whoops, the integral from 20 to m, let's call it y, of the second rule, which will be 50 minus x over 750 dx, and set that equal to 0.1 and solve for y. One decimal place, 2 marks. So I'm going the integral from 20 to m of 50 minus x on 750 dx equals 0.1, m equals, I'm looking for 22, not 77, 22.6138. Just to double check that, if I take this and go 250 from this value here, I should get a half. Whoops. And that's looking pretty good to me. So one decimal place, so I'm looking at m equals 22.6. Find the standard deviation of the spin in revolutions per second. Standard deviation, so I need to do, okay. So the variation of the spin will be the integral from 0 to 20 Okay, so the variance of x is the integral from 0 to 50, so the whole thing of f of x times x squared minus the expected value squared. So I've defined my f of x as this hybrid function. And just to double check, I've integrated from 0 to 50 of the function, and I got 1 as an answer. So if I multiply this by x squared, that will give me the expected value of x squared. And then from that, I wish to minus, and if I square this, and I put all of this in there, but I just to make that x, that will be this here, which will be, so that gives me what the variation is, and just so that equals 105.55555 continuous. Therefore, the standard deviation is the square root of the variance, which will be the answer square rooted, which gives me 10.27. So the standard deviation of x is 10.3. And I'm going to do the last question separately.